Math is really all about finding patterns. And we can think of patterns as these kind of patterns, but we can also think about all of math as being about pattern finding. So when you look at a new area of math, there's always a pattern to see.
Oh, I see the pattern. When we have a right-angled triangle, the squares on the two sides always add up to the square on the hypotenuse.
Think of math class as a time of working out patterns.
Be a pattern seeker.
Math is a way of making sense of the world, and math is everywhere in the world. If you get in the habit of seeing math in the world and thinking about the patterns you see, it can be really helpful and put you on a great learning path.
Math is a human activity, a social phenomenon, a set of methods used to help illuminate the world, and it exists throughout nature.
One really famous sequence was discovered by someone known as Fibonacci. He found a sequence of numbers so that each number comes from the addition of the two before. The first few numbers in the sequence are 112, 358, 13. Let's have a look at Fibonacci in nature.
We can take Fibonacci's famous sequence of numbers and make a spiral with them. So 1, 1, 2, 3, 5, 8, 13. Since the sequence starts with 1, let's also start out with 1, so draw a square with a side length of 1. Since the next number is also 1 in the sequence, let's add another square with a side length of 1. The next number in the sequence is 2, so let's draw another square with a side length of 2. You can probably guess the next square in the sequence. Now let's add the next square with a side length of 5. And if we do this several more times, we get 8, 13, 21. Look at this cool spiral. What's so cool about this spiral is that it's found in all kinds of unexpected places around the world. Like in a seashell, the Mona Lisa, or even Darth Vader's mask. There are other links between Fibonacci's sequence and spirals. Let's take a look at this pinecone, which has spirals similar to the ones you saw in the previous example. We can draw each of the spirals that we see. Count the number of spirals as we draw below. The number of clockwise spirals is 8. And there are 13 counterclockwise spirals. Do the number 8 and 13 sound familiar? They're part of the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13. Fibonacci spirals occur all through nature. How cool is that?
We saw lots of examples of Fibonacci in nature, but that's not the only math in nature. If we think about snowflakes for a minute, we see something amazing. Snowflakes are beautiful and all unique in their own way, but they are also unified by a single pattern. If we look closely, you'll notice that all snowflakes follow the general shape of a hexagon. So snowflakes almost always have 6 points. Why, you might ask? Well, if we take a closer look and zoom into the water molecules that make up the snowflakes, we see that water freezes in the pattern of repeating hexagons. This shows us some of the beauty and art in mathematics.